Hello, everyone, and welcome back to another Planetarium show. My name is Jessica. I'm the director of the Planetarium, and with me tonight is one of the students who works there, and I will let him introduce himself.
Hi, I'm Eli. I'm a physics undergraduate student at UMB, and I have my faithful companion here with me today. Oh, look, he nodded at me. He agrees.
So, if you couldn't tell, tonight's show is going to be about Star Wars. And we're going to take a look at kind of the Star Wars universe and explore what could be factual, what's completely science fiction, and a lot of cool stuff along the way. And Eli is going to be leading us on that journey. As usual, if you have any questions throughout the show tonight, feel free to leave them down in the comments. I will be keeping an eye on those, and we'll let Eli know when if any come up. Other than that, Eli, that's all you. Take it away.
I'm gonna make sure my screen sharing works here. Will you tell me if it looks like the right window is up?
Yes, but it's kind of small.
Kind of small. Just a second. Is that better?
Yes.
Okay, sweet. Alrighty, so welcome to Star Wars Fact or Fiction. This is a show that I have been working on for, gosh, about a year now, probably. Or maybe a little over. We had a Star Wars show in the planetarium when things were in person before, but we decided that we wanted to revamp it a little bit, and I just kind of put a new one together with some new facts and some old ones, and just a couple new things. It is going to be in the planetarium, hopefully when we reopen, whenever that is, and it'll be ready for showing in there. And there's going to be a lot more bells and whistles in the planetarium show. But I'm really excited to do this today. It's been a while since we've done Star Wars. At least a couple months, right, Jessica?
Yeah, I think so.
Yeah. Okay, so I guess I'll stop rambling and we'll move on. Is Chewie still with me? Yeah, all right. So the first thing I want to talk about is, there we go, sorry. Does the window still look good? I had to make sure that my text came up.
Yeah, looks good.
Okay, sweet. So the first thing I want to talk about is binary systems. So we know this awesome scene, which I believe kind of has the nickname the double sunset scene, from A New Hope. I don't have the video on this presentation here, but if you can kind of imagine with me, if you've seen the movies, Luke walks out and he looks over the sunset as that epic John Williams music comes in and comes to a like a zenith, and it's so cool. I definitely need to watch Star Wars tonight. But Tatooine, which is Luke Skywalker's home planet, is a planet that orbits a binary star. And a binary star is two stars that orbit each other. Binary stars are real, in fact. So double sunset scenes like this are actually probably quite common out in the universe, as up to 85% of star systems are believed to be at least binary. So any planets orbiting those binary star systems would see a double sunset, not unlike this one. And some star systems can become ternary or even quaternary. So you would have 3 stars, 4 stars, maybe even more than that. But like I said, up to 85% of star systems in the at least the local universe are believed to be binary. So there are more double sunsets than there are single sunsets. We're kind of unique here on Earth. Um, so the next thing I want to talk about is habitable zones, which is actually a really, really big theme throughout the Star Wars universe. So the habitable zone around stars is the range of like orbital radiuses, or radii rather, where an Earth-like planet could support necessary conditions for Earth life, such as liquid water and like a reasonable breathable atmosphere. This assumes, of course, that all extraterrestrial life would share the requirements of life on Earth, which we don't know if that's necessarily true or not, because we haven't found any extraterrestrial life. But assuming that they would, this habitable zone is kind of the sweet spot around the star. The hotter a star gets, the further away the range is from the star. And we see this kind of vaguely in Star Wars as different worlds exhibit different qualities we would see in planets at different locations from the habitable zone. So like, for example, Tatooine is habitable, because we see people living there. And if you're really keen on your Star Wars knowledge, Luke's aunt and uncle are moisture farmers. And so there is moisture underneath the surface, which is part of the reason why everything's underground at their home. But another interesting reason that is because since Tatooine is really like hot and arid, and you know, there's not much tree cover or anything like that, they put their homes underground, so that radiation coming from outer space doesn't go right through their house. It has to go through some ground first too. So it's kind of like an extra heat and radiation shield. Another planet that we kind of see this topic come to light for is Endor. Endor is, of course, the forested home planet of the Ewoks, seen in the third movie of the original trilogy. And Hoth, which is seen in the second movie of the original trilogy, is kind of this like frozen, like I suppose you could also call it a desert world, but just, you know, kind of frozen, snowy world that is still habitable because we have the Tauntauns and we have the oh shoot, what's it called? Oh, this isn't good. I'm lacking on my knowledge. But the like snow monster thing that Luke has an encounter with in the ice cave. Um, so still habitable, much colder, not as much liquid water. But yeah, we see that topic kind of come to life for all this stuff. Um, oh my gosh, this is one of my favorites. So Saturn's innermost moon, which is called Mimas, looks like the Death Star from a distance. It was discovered in 1789 by astronomer and physicist William Herschel. But the crater that you're seeing here that closely resembles the cannon, or like the laser cannon on the Death Star, which is called the super laser. The crater that resembles the super laser was discovered in 1980 and is named after William Herschel. And interestingly enough, the first Star Wars movie came out in 1977. So people knew what the Death Star looked like before they knew what Mimas looked like. So I imagine that some people were pleasantly surprised to see a Death Star-like object in space after the movie came out. And some people were probably even scared that a super laser would be aimed towards their home planet. But I think that's a really cool coincidence. And it makes it even cooler that the moon was discovered to have that feature after the movie came out. Interestingly enough, Herschel, the crater, emits a really intense heat from the core of the moon, much like a super laser would. So when you look at it through like thermal lenses, it's much, much hotter around that crater than it is in the surrounding area. Next, we have blaster weapons. This one was really fun for me to put together too. So the Star Wars blaster weapons, which are commonly mistaken as lasers, fire, and this is a quote from the Star Wars kind of Wikipedia called Wookieepedia. They fire bolts of intense plasma energy converted from energy-rich gas. Well, this may sound like the work of science fiction. It's actually entirely possible and has already been done. Plasma is like this fourth state of matter in which charged particles, like electrons, detach from the atoms that they're orbiting and kind of flow freely, like almost like a liquid. Um, the bolts we see here would be what's called plasmoids, or like globs, or kind of just like loose bindings of plasma, held in a distinct shape by electric and magnetic fields within the plasma. These fields can be generated as the bolt would travel by shaping it into a spheromac, which is like a kind of a donut shaped like ring of plasma that would kind of propagate with the bolt. And they only hold their shape for tens to hundreds of microseconds, but if fired at really, really high speeds, which they definitely could be, that would be, you know, absolutely plenty of time for the bolt to travel to its target. The plasma in these bolts burns at thousands of times the temperature of the sun, or the surface of the sun, and could certainly cause some serious damage to whatever they hit. While the typical like Star Wars blaster isn't really within reach with current technology, the ideas behind it aren't impossible, and they're actually, like I said, they've already been done. We can generate these like moving balls of plasma in a lab that are extremely hot and very dangerous. So it's not impossible to think that we could have some type of plasma weaponry in the future. Not that we want it, but it is within the realm of possibility. This one is also really cool. This one's kind of nerdy. In not that the last one wasn't, but in Star Wars we see very few differences between flight on a planet and flight in space, when in reality they would be completely different experiences. So on a planet with an atmosphere, your craft or your airplane or whatever is subject to a lot of forces imparted by the air that you're flying through. In order to turn, an aircraft must execute what's called a bank turn, which is the diagram you're seeing on the left side of the screen. And this is where the plane slightly tilts to one side. And as the direction of the lift force changes, it also changes the direction that the plane is moving in. So, if you've ever been in a plane and they had to turn, what they did is they actually just tilted the wings of the airplane a little bit, and then it started to follow like a circular path in whichever direction they tilted the wings in. There's no such thing as like a hard stop and a turn with airplanes. Yeah, so it's much different in space, as we'll see here. So in space, without the presence of an atmosphere or a planet supplying lift and gravity, we'd have to create our own forces to move the ship. For example, if we wanted our Millennium Falcon to move in the direction of the green arrow that you see here, we'd need to combine both forces represented by the red arrows. We'd have to have a force pushing you forward and upwards, and then the combination of those would push the spacecraft kind of up and to the right. The problem is the Millennium Falcon has only one rocket, and it's at the rear of the ship. So that means that only the force represented by the red arrow pointing to the right would be there. So the consequence of this is that if Star Wars were super accurate, the Millennium Falcon would only be able to move forward, which obviously we know it doesn't. We see a bunch of cool scenes where it's bobbing and weaving through asteroid belts and stuff. But in order to actually have a full range of movement like we see in Star Wars, we'd have to have rockets at the rear, the front, the bottom, the top, the left, and the right of the ship to provide forces that could be combined to move the ship in all directions, which we don't see in Star Wars. The other thing that always grabbed my attention about Star Wars spaceflight is that all ships are oriented in the same direction. So you can see in this picture here, all of the ships are kind of like, like up is up for all of the ships. That obviously doesn't break like any laws of physics or anything like that, but it's interesting to me that when in space, where there is really no up or down, I mean, obviously they're close to a planet here, so if all of these ships took off from that planet, that would make sense. When you're in space where there's no like up or down or proper orientation, it's weird that they're always kind of oriented upright in the same way. And you see this in other scenes too. In reality, the ships would likely all be oriented in like tons of different directions, as the planets they launched from would all be at like different angles and they, different positions and stuff like that. And they would also like change their orientation as they moved from place to place. So that's just another thing that always caught my attention. Speaking of bobbing and weaving through asteroid fields, let's discuss these issues with Star Wars asteroid fields. So in Star Wars, we see spaceships bobbing and weaving through like dense, almost like impossible to traverse like gauntlets of enormous boulders. The one that sticks out to me is when Han has an encounter with the space worm. Previous to that, he's bobbing and weaving through an asteroid field. In reality, flying through an asteroid field, particularly like the solar system's asteroid belt, would be almost no different than flying through empty space. A probe flying through our asteroid belt has less than a 1 in a billion chance of colliding with something, and multiple have traversed that region without seeing a single asteroid. They're not very dense at all. You really wouldn't see anything like this. This would be more typical of like the ring system of a planet, and we will see that in the next slide. Another problem with space and Star Wars, specifically space fights, is the fact that we see like seismic waves and like sound propagate through space. And I'm sure we've all heard the, there's no sound in space adage more than once, and that's because there is no medium for sound waves to travel through. Sound waves, like here on Earth, happen because the air molecules around you vibrate when you move something. So like when I tap my finger on the desk, the air molecules around my finger started moving outwards, and then they moved, and then it went into my ear and moved my eardrum, and that's why I heard it. But if there's no air molecules in space, you wouldn't hear anything. So seismic waves, such as the one seen here, created by the seismic charge released by Jango Fett's ship Slave One, would not really be possible in space. Oh, this next one is really fun too. Sorry, all of these are really fun to me. I'm a big Star Wars nerd, but traveling through space would be no easy task either. We'll talk about hyperspeed in the next slide, but for now, we can get a really good idea for how large the distances through space really are. So for reference, we'll talk about the Parker Solar Probe, which is the image you're seeing on the left. The fastest speed reached by any human-made object was 153,454 miles per hour, and that was reached by the Parker Solar Probe in 2018. Traveling at even that speed, it would still take 40 days to get from Earth to Mars, two planets in the same system. If we wanted to go from one planet to another at this other side of the galaxy, like the journey from, say, Tatooine to Ilum, if you're deep on your Star Wars lore, Ilum is a planet where Jedi younglings would complete their like trials and harvest the crystal that powers their lightsaber. The journey from Tatooine to Ilum would take 462 billion years, traveling at that speed reached by the Parker Solar Probe, which is about 33 times the age of the universe, or how long the universe has been around. So obviously that's going to take a little while. And then here we just kind of have like a cool comprehensive map of the Star Wars galaxy as we know it. And you know, you'd have to travel like across this whole thing to get from Tatooine to Ilum. And I'm having trouble spotting them right now, but they're across the galaxy from each other. But you know, even traveling from like system to system would take just an insane amount of time. Luckily, the Star Wars universe tries to account for this to not make the movies super boring. And in order for ships to travel great distances in short amounts of time, they enter a dimension called hyperspace. Hyperspace is kind of like a shortcut between point A and B, and in order to get there, ships must reach the speed of light. While hyperspace is a nice way to make some lore behind the mystery of going light speed and like making it possible in the universe, the bigger problem is getting to light speed. As an object's speed increases, it takes more and more energy to accelerate it any further to greater speeds. Once the speed of the object starts getting like to close to, or like even like tens of percents of the speed of light, the energy required to accelerate them further becomes like almost impossibly large. And when you get close to the speed of light, I mean, you need more energy than there is available to you in the universe to accelerate you to that speed. Additionally, rather than launch from low speeds to light speed very quickly, like we see in Star Wars sometimes, you'd have to gradually increase your speed as the kind of like, you know, when you accelerate in a car and you get pushed against the back of your chair, doing that from low speed to light speed would kill you instantly. And so you would need to go from slow to bit faster, and then you'd have to slowly increase to light speed. Star Trek actually counted for that. That's why they have what's called inertial dampeners. I don't watch Star Trek and I've never seen it, so I can't talk too much about that, but Lindsay told me about that. But Star Trek accounted for that, and Star Wars did not. Um, Another thing that I want to talk about, and this is one thing that Star Wars did get right, despite the widespread belief that it was like a misinformed error, was the famous Han Solo line, "The Millennium Falcon made the Kessel Run in 12 parsecs." At first, it sounds like Han is saying it made this drive in this distance, because the Kessel Run is like a region of space, and a parsec is a unit of distance, just like a mile. And that would be like saying I drove from Minneapolis to Los Angeles in 20 miles, which obviously sounds insane. So what Han was actually saying when he said that is since the Millennium Falcon is so fast, he was able to take a shortcut through a dangerous region of space to make the trip shorter. The Kessel Run is like a maze-like region of space surrounding the planet Kessel, which is I think like a mining and like spice harvesting planet, if I remember correctly. And it's littered with like chunks of like debris, ice, rocks, stuff like that. And traditionally, one would have to travel through the maze and avoid these obstacles to get away from Kessel, as well as avoid the Maw, which is a cluster of black holes that's kind of like dispersed throughout the maze. But what Han was really saying is that the Millennium Falcon is so fast that he was able to fly right through that like kind of maze of black holes and avoid getting trapped by their gravitational influence and cut the Kessel Run distance down significantly, all due to the speed of his ship. And you can see that on this map here. The blue line is the traditional Kessel Run route, which you see has to kind of like wind through this maze here. And the orange line is the run that the Millennium Falcon took, and it goes right through the Maw, which is that like black oval. So he just had to bob and weave through that black hole maze, which we do have a clip for when you can come into the planetarium and see the show we have on the dome in there. All right, so last but not least, and this is the one that breaks my heart the most. Talk about lightsabers. Um, Finally, we have arrived here. I know you all were thinking it. While lightsabers are probably the coolest thing I've ever seen, and I want one so bad, and if anyone can get one for me, please let me know. They don't quite work out in the way that we hope they would. Um, Lightsabers could be constructed in the same way that the blaster bolts were made that we talked about earlier with the plasma. And the plasma would have to be contained by like a self-generated magnetic field, or maybe you could make them with an actual laser built in the hilt. But the energy the energy required to consistently heat the plasma or power the laser would be way too much to be able to hold in a battery that you could keep in the handle of the lightsaber. Also, there would be no way to stop the plasma or the laser at the end of the blade, and you would be left with an infinitely long blade or a mirror that would shoot the laser back at you and then burn through the battery and hurt your hand. So those ideas don't really work. If it were made of light, you would have to stop it with some type of mirror, like I said, with the laser, which not only ruins your ability to like stab with the saber, but like I said, it would ruin the hilt, burn your hand, hurt you, and be useless. We also run into the problem of cooling the hilt, which would also take more energy and space than is available to you if you want to hold it in your hand. Not to mention the battle constraints would be devastating. Like it wouldn't look anything like a lightsaber battle in Star Wars. Since the plasma is extremely light and and it's either extremely light if it's made of plasma, or if the blade is actually light, then it's matchless. The weight balance would be all in the hilt, which is unlike a sword where the weight balance is like somewhere in the middle. And this would make swinging the blade like really awkward, like it would feel super unnatural. And also due to the fact that plasma and light aren't solid, we would get none of the cool noises made as the blades clash together. They would just go right through each other. Like it would like your only attack would be swinging it at the person's body, and that would happen right away because you're not able to block it with your lightsaber. So the lightsaber battle doesn't really work out in the way you would hope it would. Luckily, I don't want to end on a dream crushing note. So we'll take a look at the closest thing we have to a lightsaber at the moment. And this image, which is hilarious to me, this is called the protosaber, as constructed by popular YouTube engineer Hacksmith. This weapon is a lightsaber with an attached battery pack, and that actually is canon. The protosaber is a real weapon in the Star Wars universe. Before they figured out how to keep all the energy in the hilt, they did have like a hip pack with a bunch of batteries in it. And the saber itself is a tungsten blade that heats up to 3,000 degrees Fahrenheit, which is hot enough to cut through a lot of materials and is the closest thing we have to a working lightsaber at this point. I am going to say you can check out their video on YouTube if you want. I can actually find it, and or Jessica, if you want to find it and post it in the chat. You can check out that video if you want. The only warning I have to say, it's not a kid-friendly channel. They do curse in it, and so be careful of what you're watching. But you can check that out on YouTube if you want. It's really cool. And a video came out after this one. I think it just came out recently, where they made another protosaber and they had a lightsaber duel with it. It was really cool. The only problem is, like I said, it's extremely hot, so they had to wear like really clunky heat protection suits, and it didn't look as cool as you would hope. But hopefully, fingers crossed, one day we can get to having the technology for a lightsaber, because I want one. I don't know what I would do with it. I wouldn't want to duel anyone because I would be too scared of getting hurt or hurting them. But I would maybe like cut down trees with it or something. I don't know. But I want one really bad. So if anyone figures that out or has one, please let me know. And that is actually all I have. So I'll stop screen sharing.
Awesome.
And get my window back up. Okay, there we go.
Very cool. Well, you answered the one question we already had, which was about the Kessel Run,
Okay,
which came from, I believe, this is your high school astronomy teacher,
Mr.
Ben
Straw.
Straka. Yeah.
Yep.
So he did ask about the Kessel Run, but we covered that.
Yep.
So if there are any other questions, now is a great time to leave them down in the comments. And as Eli was saying, he has been working to build this into a full dome production. So we have this ready, almost ready to
Well,
go.
yeah, I had it ready in the system we have now, but
But we're switching.
so
Um,
I'm gonna have to put it back together in the new system.
yeah,
But that wouldn't be too bad, I don't think. I
no,
have all the parts ready.
it will be ready for whenever we can reopen,
Yeah.
and you'll get full immersive graphics and animations and clips
Mhm.
from the movies and lots of fun stuff. So it'll be a really fun immersive show.
Not to toot my own horn, but I made my own like Star Wars like scrolling text thing in Jessica could talk about this because I talked about it for weeks. I spent like 2 or 3 days making my own like crawling text Star Wars thing in like Premiere Pro, which I had no experience with. But I think that might be I'm gonna put that in my resume. Even if I'm not doing graphic design, I'll be like, also I made this cool thing. I don't know what it's worth, but
He did. He did lots of awesome stuff, lots of custom animations for the show. I'm very impressed with it. He did great. And I know he's excited to finally show it off in the dome.
oh, I can't wait.
So, all right. Well, let me tell you what's coming up the rest of, or over the next week. So on Saturday, we're doing our third edition of the exploration series. We're going to take a look at dark matter and dark energy, these mysterious things that we don't really know what they are, but they seem to make up most of the universe. And so we'll kind of look into that. And then next week is the beginning of May. So on Wednesday, we'll have What's Up May edition. And on Saturday will be May Constellation Story Time. And of course, since we are in May, that means we are even closer to our Astronomy Day coming up on May 22nd. We are super excited for this. We are going to be set up outside the planetarium from 2 to 4 p.m. and we'll be handing out activity kits that will contain 3 activities. These main activity kits are free. We'll also have a fourth activity available to purchase for, I think we said $10. Yeah, to purchase for $10. And it's going to be all of the equipment that you need to make your very own telescope. And it'll look kind of something like this. This is a rough prototype. And then in addition to that, we'll have some fun hands-on demonstrations that we can do with you. Some solar viewing if the sun is out and playing nice. We'll have a raffle. We're going to be raffling a Lego Saturn V rocket
Yep.
set, which is amazing and wonderful. I have one. I loved it. I think I have almost all of the NASA Lego.
They're
The
so
only
cool.
one I'm missing is the lunar lander.
Is there a Hubble one?
Little Hubble came with the new Discovery shuttle,
Oh, okay.
so I have that.
I wonder if they'll make a James Webb whenever that.
I'm waiting for them to make a Perseverance rover.
Oh, that would be cool. It would have to use like the connects looking pieces too. That would be
So because I want to say they had a Curiosity, but
we
that
have
was like limited. So like it's not in production anymore, and I can't get it.
mhm.
Which bugs me.
We have one of those in
Anyway,
the Planetarium, right?
I don't know if that one was the official set or something someone
Oh,
just
what
built.
somebody made it. Okay.
Anyway, off topic, tangent about Legos. But if you like Legos, like we do, we will be raffling off a Lego Saturn V kit, and raffle tickets will be available at the events that afternoon, and then we will pick the winner that night during the live stream. So lots of fun stuff. You can find the link to the Facebook event in the video description that has all of the information. We'll also be posting like teasers and fun kind of looks at what we're putting together for the day. We're very excited for it. It's going to be really great to get back out and see everyone in person again. Maybe not quite as large scale as Astronomy Day usually is, but it's still going to be a fun day. All right. Well, I am not seeing any more questions. We got a smiley face while we were talking about Legos. So um, I guess we will wrap it up there. Thank you, Eli, for the awesome show. As I said, definitely come by the planetarium once we're open to see the full dome version. Um, I know it is a beautiful day out there, so go enjoy the rest of the day. And we hope to see you next time. So, bye, everyone.